Jai Hind, dear students. So today in this lecture we will establish the correlation between time and frequency response, right? So to start with, first of all we will consider second order system. Consider a second order system, and as we know, the transfer function of a second order system can be written as Cs upon Rs is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. Okay. So as in this this is the transfer function of the second order closed loop system. So as in time domain, we have calculated or derived the expressions of time domain specifications, like we have calculated rise time, peak time, peak expression of peak overshoot. So we have, these are time domain specifications, and today in this lecture we are going to derive the expressions of for the frequency domain specifications. Okay, so in this transfer function we know omega n is the natural frequency. Okay, omega n is the natural frequency, and similarly we know zeta is the damping ratio. Zeta is the damping ratio, right? So if we are going in the frequency domain, then we can replace this s by j omega. Okay, so we can put s is equal to j omega. So if I put s is equal to j omega, then it will be c of j omega divided by r of j omega is equal to omega n square divided by j omega square plus 2 zeta omega n into j omega plus omega n square, right? We can rewrite this as omega n square divided by, it will be minus omega square plus j 2 zeta omega n into omega plus omega n square. Okay, now this and this is the real part in the denominator, so we can write it as c of j omega divided by r of j omega is equal to omega n square divided by omega n square minus omega square plus imaginary part j into 2 zeta omega n into omega. Now if I take omega n square common from the denominator, then it will be omega n square divided by omega n square into 1 minus omega upon omega n, or we can say omega square upon omega n square plus j into 2 zeta and omega divided by omega n, right? So these this omega n square will be cancelled out. Now we can further rewrite it, c of j omega divided by r of j omega, it will be is equal to 1 divided by 1 minus omega square divided by omega n square plus j into 2 zeta omega by omega n. Now we can consider u is equal to omega by omega n. Okay, so this expression will be c of j omega divided by r of j omega is equal to 1 upon 1 minus u square plus j into 2 zeta into u. Okay, so with this, with the help of this, we can calculate the magnitude and the angle. Okay, so if you want to calculate the magnitude of this will be c of j omega divided by r of j omega, and it will be 1 divided by under root of real part, that is 1 minus u square chi square, plus imaginary part, that is 2 zeta u whole square. Okay, so this will be the magnitude. Similarly, we can calculate the angle. Angle theta will be minus tan inverse imaginary part, that is 2 zeta u, divided by the real part, that is 1 minus u square. Okay, so this will be the angle. Now for different value of u, we can calculate the value of magnitude and angle. Okay, so if I put u is equal to 0, first if I put u is equal to 0, then in that case the magnitude will be 1. Okay, and the angle theta will be 0 degree. Okay, if you put u is equal to 0 in this and this, then you will get magnitude is equal to 1 and theta will be 0 degree. Similarly, if you put u is equal to 1, then the magnitude will be, for u is equal to 1, magnitude will be 1 upon 2 zeta, right? And angle theta will be minus pi by 2. Similarly, if you put u is equal to infinity, then the magnitude will be 0 and angle theta will be minus pi. So we can see for different value of u, or when u is we are varying from lower to higher, from 0 to infinity, the magnitude is going from 1 to 0 and angle is going from 0 degree to minus pi degree. Okay, minus pi radian. So we can plot this magnitude with respect to the u. Okay, so if I plot this, then we will get this type of curve. This is magnitude and here we have u. So this type of curve we are getting. Okay, so the frequency at which we are getting the maximum amplitude is called the resonant frequency, and this maximum amplitude, the magnitude at the resonant frequency is called the, we can say, resonant peak. Okay, so the frequency at which we are getting maximum amplitude, right, or magnitude. So this frequency is called the resonant frequency, and the magnitude at resonant frequency, this is the first point. Second point is the magnitude at resonant frequency, it is called peak resonant or resonant peak. Okay, so this resonant frequency we represented by omega r, and this resonant peak we represent by mr. So we will derive the value of mr and omega r, right? So to start with, we will take we have expression of magnitude we have calculated. So m was 1 upon under root 1 minus u square plus 2 zeta u square. So this was the magnitude. Okay, so we are talking about the maximum amplitude at the resonant frequency. So for this condition we can write dm by du, we will differentiate it with respect to u at u is equal to ur, and it should be is equal to 0. Okay, so if I differentiate this, then I will get dm by du is equal to minus 1 by 2 1 minus u square plus 2 zeta u square to the power minus 3 by 2 into 2 into 1 minus u square into minus 2u, and similarly plus this term we can differentiate plus 2 into 2 zeta u into 2 zeta, right? So after differentiation we are getting this. So I can, according to this equation, I can put dm by du is equal to 0 if I put u is equal to ur. So this will be 0 if I put u is equal to ur. So in this equation I can put 1 minus, I can replace this u by ur. So 1 minus ur square whole square plus 2 zeta ur square to the power minus 3 by 2 into 2 into 1 minus ur square minus 2 ur, and this I can write plus 8 zeta square into ur. Okay. So now we are having two terms. For example, this is term A and this one is term B, and the product of A and B is 0. So either A is equal to 0 or B is equal to 0. So if I consider that this B is equal to 0, so I can write 2 into 1 minus ur square into minus 2 ur plus 8 zeta square into ur is equal to 0. It is correct, because here we are having two terms A and B, and the product of these two terms is 0. So either A is equal to 0 or B is equal to 0. So we are considering B is equal to 0, right? So after solving this, if I rearrange the terms, I can write 2 into, we can multiply this minus 2 ur plus 2 ur cube plus 2 ur cube, right? And second term is 8 zeta square into ur plus 8 zeta square into ur is equal to 0. Again we can multiply this, so 2 into this term, so we can write 4 into ur plus 4 into ur cube. So after taking 2 inside the bracket, multiplying 2 inside the bracket, we will have this zeta square ur is equal to 0. Now we can take 4 ur common. So if I take 4 ur common, then it will be ur square, right? From here we will get 2 zeta square, right? And from here minus 1 is equal to 0. Or it can be written as ur square plus 2 zeta square minus 1 is equal to 0. Or ur square will be 1 minus 2 zeta square. Or finally we can say ur will be under root of 1 minus 2 zeta square, right? So this is the value of ur. In starting we have considered u is equal to omega upon omega n. So similarly we can say ur will be is equal to omega r upon omega n, right? Where we know that this omega r is equal to resonant frequency. This is resonant frequency. ur, we can say it is a normalized resonant frequency. Normalized resonant frequency. And omega n, we know omega n is the natural frequency. It is the natural frequency. Okay. So we have calculated ur, so we can find omega r using this equation. Okay. So I can write omega r will be omega n into ur, or omega n into under root 1 minus 2 zeta square. So this will be the value of omega r. Okay. So we have calculated the resonant frequency here. Omega r is equal to omega n into under root 1 minus 2 zeta square, right? Now with the help of this ur, we can find mr, okay, the resonant peak, because the resonant peak we are getting at the resonant frequency. So we have the expression of m, magnitude is equal to 1 upon under root 1 minus u square whole square plus 2 zeta u whole square. Okay. So at m is equal to at u is equal to ur, m will be mr. So mr is equal to 1 upon under root 1 minus ur square whole square plus 2 zeta ur whole square. right? So we can put the value of UR here. So 1 upon under root 1 minus UR square was 1 minus 2 zeta square. So I can write here 1 plus 2 zeta square whole square plus, if I open this, it will be 4 zeta square. Again, I can put the value of UR square, it will be 1 minus 2 zeta square. Okay. So after solving this, what we are getting, this 1 will be cancelled out and it will be 4 under root of 4 into zeta to the power 4, and again from here we are getting plus 4 zeta square minus 8 zeta to the power 4, right? So we can further solve this and we will get 1 upon under root 4 zeta square in minus 4 zeta to the power 4, right? Now we can take 4 zeta square common, so it will be 1 upon 2 zeta into 1 minus zeta square. Okay, so this will be the final expression of MR. So we can write it here. MR will be, that is resonant peak, will be 1 upon 2 zeta into under root 1 minus zeta square. So this will be the expression of resonant peak. Resonant peak, right? Resonant peak MR, and this was the expression of resonant frequency. Okay, so these two we have calculated. In time domain, if you remember, we have the peak overshoot. The peak overshoot was MP is equal to e to the power minus pi zeta divided by under root 1 minus zeta square. This was the expression of the peak overshoot under time domain. Peak overshoot, right? So now you can differentiate them clearly. What is the resonant peak and what is the peak overshoot? Okay, so peak overshoot we calculate in time domain and resonant peak we calculate in frequency domain, right? Now we will calculate the bandwidth. Okay, the bandwidth of the system. So for bandwidth, if I draw the graph between magnitude and frequency, so here we have magnitude and here we have frequency, that is omega. So the curve will be like this, and if I choose the 3 dB point, if I have the magnitude 1 here and this at 3 dB point, the magnitude will be 1 by under root 2. So the frequency at which this is happening will be called, we can say omega b, or we can say the bandwidth of the system. Okay. So we will calculate this omega p here. So to start with, we will start with the magnitude. So we know the magnitude is 1 upon under root 1 minus u square whole square plus 2 zeta u whole square, right? So at here we can consider ub is equal to omega b upon omega n, right? We can consider this. So this m will be 1 by under root 2 at u is equal to ub. So I can write 1 minus ub square whole square plus 2 zeta ub whole square. Okay. So this magnitude will be 1 by under root 2. Now if I rearrange the term, so I can write it as 1 minus ub square whole square plus 2 zeta ub square is equal to 2. Okay, after squaring this under root will be removed. Okay, so if I open this, I can write 1 plus ub to the power 4 minus 2 ub square plus plus 4 zeta square ub square is equal to 2. Okay, now we can further rearrange the terms, and I can write it as ub to the power 4, and if I take ub square common from this, I can write minus 2 ub square. Okay, I can take minus 2 ub square common, so it will be 1 minus 2 zeta square, and this will be minus 1 here is equal to 0. Now consider this ub square is equal to x. So this equation we can further rewrite. We can write it as x square minus 2x into 1 minus 2 zeta square minus 1 is equal to 0. So now we can find the value of x. We can use this formula. X is equal to minus b plus minus under root b square minus 4 ac divided by 2a. So if I use this, then x will be minus plus 2 into 1 minus 2 zeta square plus minus under root b square will be 4 into 1 minus 2 zeta square whole square minus 4 ac will be plus 4. Okay, divide by 2 into a, that is 2. We can further solve this. So I can write 2 into 1 minus 2 zeta square. Here we will take only positive sign because we are calculating the bandwidth. Okay, so plus, if I open this, it will be 4 into 1 plus 4 zeta to the power 4 and minus 4 zeta square, right? This plus 4 divided by 2. Further we can solve 1 minus 2 zeta square plus under root if I multiply by 4, the 4 plus 16 zeta to the power 4 minus 16 zeta to the power zeta square plus 4 divided by 2. Okay, so this 4 and 4 will add up, and this 4 and 4 will be add up, and we can write x is equal to 2 into 1 minus 2 zeta square plus under root 16 zeta to the power 4 minus 4 zeta 16 zeta square plus 8 divided by 2. Or finally x will be, if I take 2 common from here, and I can take 4 out of this, so it will be 1 minus 2 zeta square, that 2 will be cancelled out by this. So 1 minus 2 zeta square plus under root 4 zeta to the power 4 minus 4 zeta square plus 2. So this will be the expression of, we can say, x, and we have considered x is equal to ub square. So ub square will be 1 minus 2 zeta square plus under root 4 zeta to the power 4 minus 4 zeta square plus 2. Or we can take the under root of this. So ub will be under root of 1 minus 2 zeta square plus under root of 4 zeta to the power 4 minus 4 zeta square plus 2. So this will be the expression of bandwidth ub, or we have considered this ub is equal to omega b upon omega n. So from here we can calculate omega b. So this will be the expression of bandwidth. So these are some important derivations in frequency domain, and we can say to establish a correlation with the time domain, these are some important specifications. Okay, so we will stop here. Thank you.